Good morning, guys. So, I hope you guys are well. Okay, so today we'll be starting with this new topic because I believe I would have completed at least portion in the live class. No, live class is something which we cannot predict. We can complete this much portion or not. The planning never goes right. So, today we'll start with the topic called projectile motion. Right. So projectile motion is something which is under gravity. Right. If you draw it in the picture, this is a projectile motion. Oh, this one is a projectile motion. Right. That is, the motion is having both x as well as y displacement. Right. See, if the motion or the ball is, suppose this is a ball and I've drawn its path. Right. And when I track the path, the ball from its initial position to final position, the path look like this, and this motion of the ball is known as projectile motion. The ball is moving up, right? See, it's first, if I take the position of the ball, it is 0 0. Now let's say if this point, that is of P, is considered, so it will be having considered x coordinate, let's say 2, and 3 is the y coordinate. Then position of the P, I will write it as 2 comma 3, right? So that means each position in a projectile motion has both x coordinate and y coordinate, right? Each position or point can be depicted by x and y coordinate. That indicates there is two displacement in a projectile motion, one in x direction and y direction. Y, that is, direction is, the displacement is up and then down, that is, the ball is moving up and down, whereas x direction displacement is only in this direction. Clear? Formally, I hope you understood. That means a projectile motion is a two-dimensional motion. It happens in a plane. Clear? Now, when I throw a ball up, right, I will be throwing the ball up with the initial velocity, say u. Right? Let's take another figure, guys. So this is our projectile motion like this. This is the ground. Right? So I have thrown the ball like this. So this is a tangential like this. So this is the initial velocity u, and I have thrown the ball at an angle theta. When I project this, this u in this direction, it will be in here, right? So this is u, right? So u is making theta angle with the horizontal, and velocity is a vector quantity. So I can divide this initial velocity into two components. Let's say this, any component in along with the theta is horizontal component, so it is u cos theta here, and this is u sin theta. That is a short form to know, right? The component along with theta is u cos theta, another is u sin theta. Clear? Or I can write u cos theta is actually x component of velocity, right? This is in the x direction, right? So I can write u cos theta is u or x and u sin theta is uy. This much clear, right? Now let's take the another position, guys. This is another position, right? So the velocity will be in this direction. Again, the theta will be same, right? This will be theta itself, right? Now this will be again u cos theta, or I will just write it as ux. That is better. This is ux and this is uy. Clear? Now this is the top position, I believe, right? So this will be uy, right? Right? Or I can say it is v, or a final position, don't write it as, it is uy, right? And what will be ux? This direction. Similarly, the ball here, this will be uy, ux, and similarly I can draw for the entire positions, right? So let us see at the highest point, right? So I can, if I make a column, I can say initial velocity for x direction is u cos theta, and initial velocity for y direction is v sin theta or u sin theta. This much clear? Now what about acceleration? We talked about velocity, now I will talk about acceleration. You just see that, guys, when I consider the x direction, only the x direction, here ux, here also ux, right? I can say the velocity ux is not at all changing because nothing is acting on this velocity ux. It is free, right? Whereas when I consider y direction velocity, that is uy, there acts what is known as g, right? There is an acceleration because of which if I throw a ball with 20 meter per second, let's say, as it goes up at this point, let's say this point, its velocity goes decreasing, and this maximum height, its velocity even becomes 0. Clear? So I can say velocity in the x direction in a projectile motion is constant, whereas in y direction, that is uy, first it decreases, at maximum point it becomes 0, and then it again increases in negative direction, right? That is, I can say, since the velocity is constant in x direction, acceleration is 0, right? There is no change in velocity. Change in velocity is happening only in y direction. So if I make a column like this, let's make a column here for x and this is y. There is initial velocity, that is u cos theta. Here initial velocity is u sin theta. Here acceleration ax is 0 because there is no change in velocity. Whereas what would be velocity of what, or I can say what would be the acceleration of y direction? That is g, right? So in y direction there is an acceleration, and that is minus g, because of course it is in downward direction. Clear? Right? Now at maximum height the y direction velocity vy becomes 0. Whereas at maximum height still the velocity is ux itself, because x direction velocity doesn't change, right? And what is the ux? It is u cos theta. You just wrote it. So at maximum height, x direction velocity, that is ux, is q cos theta, and at y direction velocity is 0 at maximum height. Clear? That means I can say if net velocity is taken, it is actually sum of ux plus in I direction plus uy in j direction. And I know uy, or velocity at the highest point, is 0 at maximum height, but ux is not 0, right? So I can say net velocity of the ball at the maximum height is not 0. Net velocity or net speed at maximum height is not 0. Clear? That is, it has x component, it doesn't have y component. And net velocity or speed is a sum of or resultant of x and y direction. Clear? Right. Now we are going to learn some terms related with projectile motion, and in your school examination a lot of times these derivations are asked. Okay. Now what and all are the common terms you have to know? I will draw another diagram, that is better, without much terms. Right, this is the projectile motion. I'm just drawing the starting, guys. This is our initial velocity. Let's say this is theta, this is u cos theta, and this is u sin theta. Right, now we are considering, and I can write what is the acceleration. That is the first point we are going to write. Acceleration I can write for any vector quantity. Acceleration is ax plus ay j cap. Right, now we just told that x component, or in x direction, there is no velocity because ux is constant velocity in x direction, right? Or I can say in horizontal section, right, the velocity is constant, so there will not be any acceleration, so this term becomes 0. So I can write acceleration as just ay j cap. Clear? And I just told you what is the value of ay, that is gravity downwards, that is minus g j cap, that is acceleration. Clear? Now similarly, let's talk about velocity. That is, let's take that as the second point, that is velocity. Now what is velocity? That can be also net velocity is sum of its x component plus its y component, right? So uxi plus uy j cap. And what is ux? That is horizontal, that is u cos theta I cap plus uy is u sin theta j cap, right? Right. Now, third point, these are some of the terms, guys. Third point which we are going to write is how to write displacement in x and y direction. Displacement, right? That is, you have to write a displacement equation for x as well as equation for y, right? Now let's first talk about x-axis. What is x equation for any section? It is x is equal to x naught, that is final x position is equal to initial x position plus ut plus half gt square, right? And I told you, if it is in x direction, you can even write it in the x component because it's a two dimension, right? So x is equal to x naught plus ux t, that is velocity in x direction, plus half gxt square, right? Now in x direction, see, we have drawn the projectile motion like this, that is initial point is origin, right? So it is 0 0, so x naught, that is initial position, is 0, so I can avoid writing it. And what is initial velocity in x direction? U cos theta into t. And what is the acceleration? That is gx, I can write it as ax, right? So in place of gx, I was supposed to write at squared. I'm sorry, wrote it as gt squared. It was a common problem, guys, after doing a lot of problems in downward motion, right? So let's say it is ax itself. Let's write it as ax. Okay, that is a common formula, but usually we have done a lot of problems like this, so I usually make a mistake. Okay, so it becomes at squared, right? And this is axt squared, right? Now what is acceleration for a horizontal motion? Horizontal section velocity is constant and ax is 0, so I can just write x is equal to u cos theta into t, right? This is the equation for what? X direction displacement. Now similarly, if you are asked for y displacement, that is uyt, right? Again, y origin, right? Y displacement starts from the initial displacement or position is 0, plus half ayt squared. I will not make the same mistake again. So uy, what is uy? U sine theta, right? Vertical initial velocity plus t into t, half ay is what? Ay is g downwards, right? And this minus, so here I am supposed to write it as minus gt squared. Now that is equation for displacement of the body in the projectile motion in y direction. Clear? Right? Now you have the next term, top 3 now. Now I will write 4. Right? Now you are asked components of velocity. Right? Components of velocity means you are asked what is Vx and Vy, what final velocity. Right? Sorry. Now, what is the components of velocity? Vx, sorry, I didn't select the pen. Vx, and then there is Vy. What is Vx? That is rate of change in displacement in x direction. Now rate of change in displacement in y direction respectively. And in place of x, I can write u cos theta t as per the previous one. So u cos theta is a constant term. I can write it outside. It is u cos theta dt by dt. Now dt cancels out, and hence I can write it is u cos theta only. That is our velocity in x direction. Now similarly for this one, d by dt, it is u sin theta minus half gt square. Right. Now how would I differentiate? And there is a t, sorry, no? There is a t here, I forgot it. Minus half gt square. Now again, u sin theta, first I will differentiate u sin theta t. So u sin theta is a constant term, so dt by dt, that cancels off. Then there is half g constant, and I will write d by dt of t square. Right? Now what is the differentiation of t square? It is 2t. So u sin theta minus half g into 2t. So 2 cancels out. So I will get the final answer, u sin theta minus gt. That is our velocity in y direction. right? Final velocity in y direction, and u cos theta is final velocity in x direction, right? And at maximum height, if someone is asked what is tan theta, I'm just giving an example. You will write it as vy by vx, right? And at maximum height vy is 0, so tan theta will be 0. Someone is asking you, you can tell that answer like this, right? Now let's move on to the next section, guys. Now what was the point? I forgot. 5 or 6 or 4. Now fifth point, that is nature or path of projectile. That is, you are asked what is the path of the projectile. You have to say what it is. I will say now the answer is parabola. That is, path of the projectile is a parabolic form. Now you are asked to prove it, right? So how can you prove? The path of a projectile is decided by x and y component, right? That only says how you are moving, right? You have to have the coordinates. So the parameter which decides the path of the projectile is x and y component. So, or x and y displacement. So x is written as what? U cos theta t. You have written it previously. Let's mark that as first equation. Now y is equal to u sin theta t minus half gt squared. That also you have learned, make it as second equation, right? Now from the first equation, I will write t is equal to x by u cos theta. From this equation, I will write it as u cos theta, sorry, x by u cos theta, and I'm going to put this value here in place of t, so that y is equal to u sin theta. In place of t, it is x by u cos theta minus half g x squared by u squared. Sorry, u square looks very odd. Okay, u squared cos squared theta, right? Now what is, I can cancel u. Now sin theta by cos theta is tan theta, so I will write it as tan theta x, right, minus half, sorry, g divided by u squared cos squared theta into x squared, right? That is your y. Now for a parabola path equation, it is ax plus or minus, it can be plus or minus bx squared, right? This usually, okay. Now that means in place of a you are having theta, in place of b you are having half g u squared by cos squared theta, right? So that means these two equations look very similar, or I can say equation of path, right? This is the equation of path of, that is the equation having both y and x, right? That is the equation of path of a projectile is similar to the equation of parabola. Hence, path of projectile is a parabola. Clear? Right. Now the next term which we have to learn is time for reaching the maximum height. That is, if you are having again the diagram, is this a projectile motion? You are asked what is the time to reach from here to here. That is your initial position, this is your final position. Let's say the time for reaching from initial to this maximum height f is tm. Let's write this as tm. That is a time to reach the maximum height, right? Clear? Now, so what and all you know about maximum height? You know at maximum height the vertical component of velocity is 0, right? And you know what is the vertical, this is a, you see, this becomes initial, obviously for this scenario this becomes the final. So final velocity equation in vertical section is u sin theta minus gt, right? Now here what is the time interval I'm going to name? I'm going to name it as m. So tm I will write here, right? So what is vy at highest point is 0, u sin theta minus gtm, right? So I can write tm is equal to u sin theta by g. Now this is the time which a projectile or a ball which is undergoing a projectile motion takes to reach its maximum height. Clear? Now what was the point? No, I didn't write the number. This was 5. Then obviously this should be 6. Right? Time to reach the maximum height. Now the next point you will have to write is 7th one. That is time of flight. That is for how much time the ball or the body which is undergoing projectile motion remains in air. Or I can say you are asked when a body is undergoing projectile motion, you are asked what is the time from this initial position to this final position. Right? So how would you calculate it? You know that when a body is moving from here to here, right? So this point is 0, 0. Right, now let's say this point is 6, 0. That means it is having displacement in this direction. What is the y coordinate then? 0, right? Again here 0. That means there has been no displacement in which direction? There has been no displacement in y direction. That is y is equal to 0. Clear? Now what is the equation for y? Y is equal to u sine theta t minus half gt square. Right, now in place of y I'm going to write it as 0. It becomes u sine theta t minus half gt square. Now let's bring the common terms, or sorry, some of the terms in LHS. So sorry, I wrote it as sine now. Let's bring half gt square. So this is half gt square is equal to u sine theta t, cancel 1 t, right? Then you can get, let's write it as t for here, t full, right? Full time, tf here. Okay, so tf becomes 2u sine theta by g. Right? Clear? Now this is an additional point I'm going to write. What is the relationship between tm, that is time to reach the maximum height, and tf, that is for time of flight? You will see what is Tm. It is u sine theta by g, right? And what is Tf? It is 2u sine theta by g, right? That means I can say time of flight is 2 times time to reach maximum height, right? That means if a projectile takes some time to reach the maximum height, he will take the same time to reach here also. Clear? Right? Now let's move on with the next section, that is maximum height of a projectile. That is how much high he can move from his position. Clear? Now, let's say a diagram is drawn like this. Right, you are asked what is this height, right? Now I know a object to move from here to here, he takes a time, that is maximum time tm, right? Now what type of displacement I am going to consider? If I have to measure h, I am going to consider the displacement as y, right? And we have to measure y, right? Y coordinate here, right? So y equation is u sine, okay, u became a, u sine theta t minus half gt square, right? Now in place of t, it is for tm, right? So it is tm, and here also tm. So it is u sine theta. What is the tm equation? It is u sine theta by g. Now this and all equations you guys have to by heart. There is no other way. Minus half g tm square. Sorry, in place of tm I have to substitute now. So I will write it as u squared sine squared theta by g squared. So I can cancel 1g, right? So this equation becomes u squared sine squared theta by g minus half u squared sine squared theta by g, right? So this is something which you can write by yourself. but I'm still writing u squared sine squared theta, that is 1 minus 1 by 2. So it is half u squared sine squared theta by g, right? Or I can write, so this y is actually h, right? Maximum height. So h is equal to u squared sine squared theta. 2 I'm going it inside, it becomes 2g. That is the maximum height achieved by a projectile. Clear? Now, what was the number? Again, I forgot. I didn't write the number. 7, 8. Sorry. 8. So, next number 9. That is horizontal range of a projectile, right? That is capital R, right? Now, what do you mean by horizontal range? It is better if I draw a diagram again. This is a projectile motion, right? So, horizontal range means what is the maximum displacement in x direction. So, this is the horizontal range. So, I know when this is the initial position and this is the final position of the ball, what is the time covered for this displacement? That time is known as time of flight. I will write it as TF, right? And what type of velocity contributes in the x direction? It is what? Ux, which is equal to u cos theta. That contributes for the displacement in x direction, right? And time of flight is TF. So obviously range, which is the distance from here to here, is velocity into time. That is u cos theta into TF, right? So in place of TF, what is the equation? I hope you remember 2u cos theta, u cos theta into 2u sin theta by g, right? Or I can bring u outside, becomes u squared 2 sin theta cos theta by g. Now there is a trigonometric equation for 2 sin theta cos theta, which is sin 2 theta, right? This is range, right? Now range will be maximum. When will be the range maximum? When sin 2 theta is 1. That is when will be sin, this will be when 1, that is when sin 90 degree, or I can say 2 theta is equal to 90, or theta is equal to pi by 4. That is range will be maximum when the angle of projection, which is, oh, I forgot that theta is called angle of projection, right? The angle by which you throw a ball for a projectile motion, right? That is 45 degree. So maximum range occurs when you throw a ball at an angle of 45 degree. Clear? Right? Now, how will we range for a question? Okay, let's move on with a small numerical question. Right, you are given a projectile motion from ground to ground. Ground to ground means like this, okay? Ouch. And you are asked in which condition or what will be the angle when maximum height will be equal to range. That is, when you throw a ball, this value is equal to this value. Both are having same measurement. You are asked the angle for it. So how would you write? You should have the equation for h, which is u squared sine squared theta by 2g, and range is u squared sine 2 theta by g. All right, now let's remove this one. Right, now this u squared sine 2 theta, I'm going to write it as 2 sine theta cos theta, because it is better to cancel something. Now this g cancels out, right? And u squared cancels out. 1 sine theta cancels out. So I have sine theta by 2 is equal to 2 cos theta, right? Or I can write tan theta is equal to 4, or theta is equal to tan inverse 4. Clear? Right? This much is simple. Right? Now let's make another thing. The similar question. This is, if you know the equations of a projectile, it is very easy to do a problem in projectile. Now similarly, I'm going to ask you. Now if the height, maximum height is 30 root 3, right, and the horizontal distance, that is called range, is 120 meter, right, find the initial velocity and your angle of projection. That is a question, right? So how would you do it? You know height is, maximum height is 30 root 3, and you know the equation is u squared sine squared theta by 2g, right? So you are going to equate it. Similarly, you know range value, which is 120 meter, and its equation is u squared. I'm not going to write sine 2 theta. Why? Because it's easy to cancel out, guys. So write it as 2 sine theta cos theta by g. This much clear? Right. Now, what would you do? How can you calculate this answer? What I'm going to do is I'm going to divide these two guys like this. Right? That is h by r. What would I have to do for that? H is u squared sine squared theta by 2g. When it is divided by r, then g comes up. Then there is u squared 2 sine theta cos theta. Right? So 1 sine theta cancels out. U squared cancels out. G cancels out. Or actually you guys could have used the first step, but I'm writing it entirely. Okay, so it is sine theta by cos theta, and there is sine theta by 4 cos theta, right? Then that is, what is h by r numerical value which is given? That is 30 root 3 by 120, right? Now 0 0 cancels, 3 12 cancels, 4 4 cancels. I get tan theta is equal to root 3. Right, and for which angle theta, tan is root 3, theta is 60 degree, or I can write it as pi by 3. Clear? Now again, what is the second part? You are asked what is the, you got the second part, that is you got the angle of projection. Now if you are asked what is the initial velocity, again you know the horizontal range, right? You got the theta, u squared sine squared theta by 2g is equal to 30 root 3, right? Now u squared, what is sine squared theta? Sine squared pi by 3, right, divided by 2 into 10, that is equal to 30 root 3. Now u squared, that is sine 60 degree, it is root 3 by 2 divided by 20, so I am supposed to write 2, that is 30 root 3. So I can cancel this root 3, right? So it becomes this u squared by 40 is equal to 30, or u squared is equal to 1200, or u is equal to 10 root 12, right? Or I can write it as 10 into, this becomes root 3 4, right? So it becomes 20 root 3. That is your initial velocity. Clear? Right? Now this is the next section, guys, which is not present in your book, right? But the entrance portion section, it is very important. That is projectile motion, which is from a height. That is, this is, oh shit, sorry, I cursed, didn't mean to you guys, right? This is let's say a tower, right? You're going to throw a ball like this. What type of motion will it have? I'm not dropping, guys, I am throwing. That means, and I'm meant to throw it in horizontal direction, not vertical. Vertical condition you have learned in the previous section, right? That is a one dimension motion. When I throw a object in horizontal motion, it has some horizontal displacement. After that, it likes to move in this direction, right? So this is a full projectile, so I can say it is a half projectile, right? Like this. I hope this much is clear, right? So when the object is moved in this direction, I know I'm throwing it in a horizontal direction, so it is having a velocity, let's say ux, right? Now What will be the velocity in vertical direction? It is the maximum height, so obviously vertical velocity is 0. Now let's say its position here is here. Now again ux, but uy, now it is not 0, it will be negative value, but it is increasing, right? Gradually again it is ux, uy, much more higher negative value, and this goes on until it reaches ground, right? And I see, just like the previous projectile motion which you have learned, ux is always constant. This ux is constant, and uy was 0, right? That it increases in negative direction, right? This much clear. These are the constant. So ux, it is constant, means there is acceleration in the x direction is 0, but there is y direction acceleration, which is minus g. Common sense, right? Now suppose we are going to do a simple problem, so by which you can understand it. Now this is a tower, and you are throwing a ball with the 5 meter per second velocity in this horizontal direction, and let's say this tower is having a height of 20 meter, right? And you are asked time which is taken by, many things we will do. Let's ask with the first question, what is the time which is taken by the particle to reach ground, right? So we know the displacement is happening in y direction, like this, right? It is happening both in x and y direction, but we know only y direction parameter. Why? This is the initial position. Let's say this is 0. This is the final position, means it is 20 meter, right? So y is equal to what? Plus or minus? Minus 20 meter. I told you, take all the direction in this direction as negative, and all the direction upward is positive. Now, what is the initial velocity? I'm going to only deal with y. Why? I don't know anything about x, guys. I only know x velocity, which is not making any sense. So time of flight means you are asked from here to here, right? So you better take the parameter which has been given to you. So y, I took it as minus 20 meter. Now what is the initial velocity in y direction? It is maximum height, right? So the velocity is 0, right? I know ux, let's keep that aside, 5 meter per second. Now what is acceleration in y direction? Ay, it is minus g. I will take it as minus 10 meter per second square, right? Now what is the equation for y direction, displacement? That is uyt minus half gt square. I hope you understood why I put minus. It is for g. So sy is minus 20, ui becomes 0, minus half g t square, right? So from here I can get the value. Let's do a calculation. So minus minus cancels, 20, then 5t square. So t squared is equal to 4, or I can say time is 2 seconds, right? Clear? Now you are asked what is horizontal range, right? Now horizontal range, again I'm going to draw the picture, guys. This, so in this figure, if this is the ball falling, which is the horizontal range? This is the maximum height, which is already known for 20 meter. This, which I have just drawn, is the horizontal range r, right? Clear? So that means what type of displacement I am going to handle? I am going to handle x direction displacement, and that x direction displacement is that has been asked here, right? And I know velocity in x direction is 5 meter per second in every point of this projectile motion, and I know since the velocity in x direction is 0, acceleration is also constant, acceleration is 0, right? And this is a very, very important point, guys. When the ball is undergoing this motion in a half projectile motion, the time the ball reaches or achieve this one, that is from this initial position to this final position, by that, let's say that time is t, right? Is if the ball has taken the time t from moving from here to here, during that time interval only the ball has achieved this displacement, right? As t displacement is for both t time is also for both condition, that is x displacement and y displacement, right? That has to be understood. That is, I just told you, or we have found that the ball took 2 seconds to move from here to here, right? So the ball would have taken the same 2 seconds to move from here to here, right? So that means to cover the range R, the time he took is 2 seconds. Clear? Right. So now we are going to go for Sx is equal to uxt plus half axt square. Now, what is Sx? I don't know. That is supposed to be found. What is ux? It is 5. T is 2 second. Half. This ax is 0. So I don't need to write anything. So what is displacement in x direction? 10 meter. That is your range. Right, so the ball has moved 10 meter from the base of the tower to the final position. Yeah, right. Now let's move on to the next question. Velocity of ball when it hits the ground. The same question, okay? When it hits the ground, what will be the final velocity? Right, you know final velocity in x direction will be 5 meter per second itself, right? And you are asked what is the final velocity in y direction. That is a question. So this y has been direct asked, mean you will only deal with y parameters. You know uy, initial velocity in y direction, maximum height is 0, right? Now what is ay? We found it as minus g, or I take it as minus 10 meter seconds. And what is the time which is required to hit the ground? T is equal to 2 seconds. Right? Now, it is simple. You know what is V is equal to U plus AT, right? So, here I can write Vy is equal to Uy plus Ayt. Right? Clear? And you know this parameter goes off as 0. Right? So, I can write Vy. What is Ay? It is minus 10. And what is T? It is 2. So it is minus 20 meter per second, which is the velocity when the ball just hits the ground, right? And someone asks you that you got velocity, what would be the speed, right? If you are asked, you got the velocities equation and someone asks you what will be the speed, then understand that speed is actually velocity itself, right? But here this displacement and distance is same, right? So here I can just find the magnitude of velocity, which is Vx squared plus Vy squared, right? What is Vx squared? That is 5. What is Vy squared? We just found it as minus 20 whole square. So it is what? Root 25 plus 400. So it is root 425. Okay, I'm not finding the exact root section. I'm just telling you. Okay, now the last section, if someone asks you find the angle theta when it falls on ground. What do you mean by that? See, this is the height, a ball fell, this is the ground, right? So this direction velocity is Vx, this velocity will be Vy, right? So if this ball, if I'm drawing a direction for net velocity, it will be in this direction, right? So theta is this one, that is the angle which the net velocity makes with the ground, right? So it is very easy. You know Vx is 5 meter per second, right? You know Vy is 20 meter per second, right? So what is tan theta? It is Vy by Vx, right? Velocity in vertical y section, or similarly I have taught you tan theta is for any vector is Ay by Ax, right? So Vy by Vx is 20 by 5, or you will get 4. So theta is equal to tan inverse 4. Clear? Now I've tried to include more problems for respective theory, guys, because that makes the theory section thorough. Okay, so don't mind if I am doing a lot of problems.